So hey folks, here is the video on two-dimensional motion. I'm trying to give you basic ideas. This is especially for college physics students, but it could help anybody understand the fundamentals of motion in two dimensions. So to start off, we start with a problem on one-dimensional motion where you have an object that is dropped from a height of 98 meters and coming down vertically. We're going to find the time it takes to hit the ground. Again, this is one-dimensional motion, just to show you the difference. So the height is 98 meters, and we're going to find how long it takes for the object to reach the ground. All right. So what are the given quantities here? Let's start with the diagram. So you have this point A here, and ground is at B. So 98 meters is the vertical displacement. We have the initial velocity as 0. And the acceleration is, of course, negative 9.8 meter per second squared. The displacement, delta y, is negative 98 meters, and we've got to find time. So the equation that connects these quantities is delta y is v naught t plus 1/2 at squared. Plug that into that, and then you get the time as 4.5 seconds, because when you take the square root of 98 by 4.9, you get 4.5 seconds. So that's one-dimensional motion. Now, just a twist on this. What if the object was not dropped from that height? What if it was given a horizontal velocity of 10 meters per second? Will it take the same time to reach the ground? Yes, of course it will, because when you project it horizontally, the initial vertical velocity is still 0 meter per second. So none of these quantities change. It'll take the same time to hit the ground. Let's do that. So here we have the object, which is now thrown or projected horizontally from that height, the same height of 98 meters. And we're going to find the time that it takes to hit the ground, right? So the horizontal velocity of 10 meters per second does not change the time it takes to reach the ground. Instead, what it does is, instead of the object landing straight down to the ground, it's going to have a horizontal displacement. So that's the only difference. And we can find the horizontal displacement after we get the time. So once again, without wasting any time, since the vertical quantities are the same, like the initial horizontal, the initial vertical velocity is still 0 meter per second. A is negative 9.8 meter per second squared. Delta y is still negative 98 meter. When you find the time, you are going to use the same equation. Of course, the diagram changes because now you have an initial horizontal velocity. But the vertical quantities, like I said, are still the same. So no change there. So when you work it out using the same quantities and the same equation, you're going to get the same time, of course. And the time is going to be 4.5 seconds as shown down here. So you do the same thing. You get the time as 4.5 seconds. Now, once you get the time as 4.5 seconds, we can find the horizontal displacement. But remember that the horizontal velocity is not affected by gravity. Horizontal velocity never changes, especially because we're not considering air resistance. So when the object travels with that horizontal velocity of 10 meters per second for that much time, its horizontal displacement is going to be the product of that velocity and time. So as I've shown here, the horizontal velocity is a constant. And so you get 10 times 4.5, 45 meters. So the object is going to fall 45 meters away from where it was projected. So here is another question with another twist to it. Now, in this case, the object is projected at 10 meters per second at an angle of 30 degrees to the horizontal. So instead of projecting it horizontally, Now the object is projected at an angle of 30 degrees to the horizontal from the same height, from the height of 98 meters from the ground. Once again, you got to find how much time it takes to reach the ground and what the horizontal displacement of the object will be. Now, this is very important and crucial to know that once you give a velocity at an angle, you got to resolve it into its vertical and horizontal components. So that's the velocity of 10 meters per second, but you got to resolve it into the horizontal component, which will be 10 cosine 30 degrees, because that becomes the adjacent side of the right angle triangle, and then the vertical becomes 10 sine 30 because that will be the opposite side. So 10 sine 30 is 5 meters per second and 10 cosine 30 is 8.7 meters per second. So once again, that is from basic trigonometry. You got to break that velocity into its horizontal and its vertical components, and they are physically independent of each other. So now we'll find the time always using the vertical component. So the vertical component is 5 meters per second. The acceleration is negative 9.8 meters per second squared. We know that delta y is again negative 98 meters. The equation that connects them is again the same we've been using. Delta y is v naught t plus 1/2 at squared. Plug it into that. This time, fortunately or unfortunately rather, you get a quadratic equation. When you rearrange the terms and then you try to solve the quadratic equation, you have to use the formula minus b plus or minus square root of b squared minus 4ac by 2a. And looking at this equation, you see that a is 4.9, b is a negative 5, c is negative 98. So when you plug it into the quadratic formula, you get this. 4 times a is 4.9 times c is negative 98. So the two there, the negatives there, make a positive actually, because you have two negatives there, so that's going to make a positive, and you get 1920.8 under the square root. When you take the square root, you get 43.83, and then when you plug it in, you're going to get 5 seconds. So, I mean, of course, you get a negative time, but time cannot be negative, so we exclude the negative value of the time and only use 5 seconds. So I hope that makes sense. And once you get that time as 5 seconds, you can calculate the horizontal displacement. Once again, remembering that the horizontal velocity never changes. And the horizontal velocity was 8.7 meters per second. So to get the horizontal displacement, you multiply the time with the 8.7, which gives us a 43.5 meter. So just to review, remember that when you're given a velocity at an angle, you always got to break it into its horizontal and its vertical. Use the vertical component to find the time, and then use the horizontal component of the velocity to find the horizontal displacement. All right, in the flow and nature of things, let's try to do another problem. Here you have a boy who throws a ball with an initial velocity of 25 meters per second at an angle of 40 degrees to the horizontal. How high above the projection point is the ball after 2 seconds? So once again, this is like the previous example. The ball is thrown at an angle of 40 degrees to the horizontal, and it's given a velocity of 25 meters per second. But the question asks us to find how high above the projection point is the ball after 2 seconds. So we're looking for delta y. We're looking for the vertical height. So first, as always, break that velocity into its two components. So the horizontal is 25 cosine 40, and the vertical is 25 sine 40. 25 cosine 40 is 19 meter per second, and 25 sine 40 happens to be 16 meter per second. So the acceleration is negative 9.8 meter per second squared. I may have said that a million times in my life now. And time is 2 seconds because you're looking for the vertical displacement after 2 seconds. So we're looking for the delta y. Once again, the equation is the same we've been using. Is delta y is v naught t plus 1/2 at squared. And when you plug it into that equation, carefully, 16 times 2 plus 1/2 times negative 9.8 times 2 squared. So 16 times 2 is 32, and then you have negative 19.6. So you get 12.4 meter. So I'm just trying to show you what that means. And it started off from here, and after 2 seconds, delta y is 2.4 meter. And this may not be exact. Actually, it has to be a little bit after its maximum height. It's coming down. You will see that. So here is the last question in this edition. Here is the same question. A boy throws a ball with an initial velocity of 25 meter per second at an angle of 40 degrees to the horizontal, just like the same question. And we already found the first part. Now we got to find the velocity of the ball after 2 seconds. What's the velocity of the ball after 2 seconds? All right, first step, resolve it into its vertical and horizontal. We already got the vertical component as 25 sine 40, which is 16 meter per second, and we have the acceleration, and the time is 2 seconds, and we're looking for the final velocity. So that's the change there. The final velocity along the vertical. And when you look at these quantities, you see that the equation to be used, of course, should have all those quantities, and it's Vfy is V naught y plus At. So V naught y is 16, A is negative 9.8, T is 2. So when you make those calculations, you're going to get 16 minus 19.6, which is negative 3.6 meter per second. So just to illustrate, it starts from here at 16 meter per second, which is the vertical component, and then after 2 seconds, the vertical component has become negative. So you can see that it has become negative. That means it's pointing in the downward direction now, and it's small. It's negative 3.6 meter per second right there. So also remember, the horizontal velocity never changes. So all throughout the motion, the horizontal velocity remains at 19 meter per second. So even after 2 seconds, of course, it's 19 meter per second. So now what do we have? We have this object which has a vertical velocity of negative 3.6 meter per second and a horizontal velocity of 19 meter per second. We got to find the resultant of the two. So what I did here is I just drew the 3.6 on the other side. So it's 19 here, 3.6 here. The resultant is going to be this. Of course, you find that by using the P theorem, where you add the squares of those two numbers and take the square root. Here I'm saying that, oh, and I made a mistake. This is supposed to be Vox is equal to Vo1. Vox is equal to Vfx. Sorry for that. Along the x-axis, the velocity does not change. So both of them are supposed to be x, and that's 19 meter per second. So when you take the resultant, you are going to get root of the sum of the squares. So 19 squared plus 3.6 squared. So even if you put negative 3.6 squared, the square of a negative quantity becomes positive. And so you get it as 19.33 meter per second. So I guess, folks, that this gives you a preliminary idea of how to work out problems in 2 dimension. Thank you and wish you the best.